Yeah, so let's add some metadata. And for that, we can switch over to example 10. And let's make this different. Open folder. I trust myself. So again, I have linked the Doxygen pages in here, but you don't really need them. So I'm going to show you some examples on how to define the metadata for the meshes. So let me just quickly look at the data that we created earlier again. Let's just take the first one, the 9th one. All right. And then so we are here at the point that we have retrieved the mesh, the image mesh from the OpenPMD object hierarchy. So in order to, for example, define the access labels, here you see the name and the default value. The default value is wrong because we are looking at a two-dimensional mesh, so we should set that specifically by saying image.set access labels. This is now a standard vector, x and y. Oh wait, we are in terms of alpaca, so it's y and x, right?
Yes.
Okay, I just noticed that the subsequent solutions then will have this one wrong, I think.
But most likely we are quadratic, so you don't know.
That was the problematic thing for me while preparing this workshop, because this thing was quadratic. I never saw if the things I was doing were right. So that's how you would define a standardized attribute that is supported by the OpenPMD API. You can also set custom comments or custom attributes by specifying generically set attribute and then specify some value. So in this case, a string value, the type is automatically deduced. Otherwise, you can also specify the type as a template argument. Data order we are going to ignore because it's deprecated. In earlier versions of OpenPMD, you were able to specify the data order by giving either C or R for column or row major. But the data order is now just specified by specifying the access labels accordingly by giving the, and now I have a 50% chance of saying it right, by giving the slowest moving component first, I think.
I'm not sure what your definition is.
I would need to look that up again. So the, I will look this up in the... Yeah, then it's that, yeah.
Is it in the startup?
It's in the upcoming for 02.
I will look up.
Yeah.
Does this mean my access labels really need to be X, Y, and Z? Or
No, you just take the data as it is and store it. And then, depending on what the logical order is, you say it's either x, y, z or it's z, y, x. So OpenPMD doesn't care about the order in which you give that. Just implementers need then to know, okay, the first component that is specified there is the slow moving dimension, and depending on if you're in Fortran or in C or in CUDA, you need to access it accordingly. All right, so the Cartesian geometry is still fine. The grid global offset we would want to set to which value probably?
0.
Exactly, yeah, 0, 0, because we just have one mesh, that's the global thing. Now the next ones that are in here are grid spacing and grid unit SI. Yeah?
As I see typing blocks, they just the care about or specify the
Floating point versus double? Generally not. I don't know. It depends on the...
more general the data type. If I put in integers there, would it store that as integers, and it would be my task as a user to like adjust accordingly, or would it do an implicit conversion here?
There is a set of predefined data types, which includes the most common ones. We work in terms of non-explicit data types, so we have byte, int, long int, all of that signed and unsigned, so the most common data types are there.
That is an interesting answer that I would have maybe asked the question for afterwards. What I meant was more like, if I set concretely grid global offset, is it defined that it floats no matter what I put in, or does it just store ints there if I put ints there?
So the question is, if you put integer values there, is that going to put integers for the... So basically it depends a bit on the specific attribute and how it's defined. Some of them are defined to be double always. Some of them are defined to be floating point and accept all kinds of floating points. So in this case, I would actually need to look that quickly up.
Okay, the general answer was enough for me. I'm not particularly interested in grid global offset.
Okay. There's another question I saw in the chat. Does OpenPMD give any mandate or recommendation on naming additional attributes? Not really. So the common case is to have a camel case name, but beyond that, there is no real standardization on how to name additional attributes that you want to use.
So the order for this is from slowest to fastest.
Okay, thank you for looking it up. I just see the answer by Maxime. Event-based data collection involves gathering information related to specific events, including when, why, and how they occurred, and all the related parameters that might characterize such an event in the physical space. Maybe the only difference that I see right now that how the event data is stored and queried. Data file will be the only file. I mean, isn't that just the iterations, the single events on when output is being created? Because you can use iterations to model that kind of thing, if I don't get you wrong right now. I would need to look into that in more detail.
Maybe suggest to open an issue in the standard repository to ask about.
Okay. Yeah, so the suggestion from the auditory is to open an issue in the standard, or to actually, I can advertise that now already maybe, by going to the end of the slide deck, by joining our Slack channel, openpmd.slack.com, and chat with us there. So either open an issue or go there.
Related question.
Yeah.
Because I was thinking about event-based collection could be pretty many events with pretty small data each. Is there a like performance hierarchy of or preference between like iterations and actual records in there?
So the one thing that you should definitely pay attention to is if you have many small iterations, then it's probably best not to write a new file for each of them. But the most performant one in that case is the one that we have specifically for ADOS, which is variable-based encoding, which we are going to see later today, but basically it doesn't even create a new group for each iteration. It just uses attributes and data sets that can have multiple versions. So you have one fixed hierarchy that is visible on one short terminal output, basically, and you see that you have it in 400 versions or so. That being said, the background of OpenPMD definitely is a simulation such as Pico and GPU, where you have semi-regular huge output, and it's currently well optimized for that. And the project to optimize for the kind of workflow that you are suggesting, so many small iterations, is something that is currently being worked on and not yet perfect, but we are aware of it. The current release actually brings huge benefits already for that, but we are not fully there yet. Okay, let's continue maybe defining now the grid spacing. So we are currently within a toy example, so we can basically make something up. So let's say we are giving the grid spacing in terms of millimeters. So what would I write into here for getting millimeters? Exactly. Or that, yeah. Or I could just spell it the way that you said, yeah. And then we will say that we have a grid of 5 millimeters per cell. We don't care so much about the position, so let's just say we represent the center of each cell, so image set position. There is no time offset, so we'll keep with the default for this one. And finally, we are going to give a unit. In that case, or in this case, we are going to use Kelvin, so a temperature. And that is given as a C++ map, so theta has exponent 1. And maybe let's say we are dealing in terms of tens of Kelvin. So those are the mesh attributes. Yeah.
One thing you've not defined is the geometry. Think that was in the attributes.
Because the geometry is by default set as Cartesian, and we can use the default.
Are there others?
Come again?
Are there others?
There are others. I don't know them by heart, but I can look.
Are there irregular ones?
Wait a minute, I can show you their names in a second. So the question is about the predefined geometries and which ones there are.
Cartesian, killer mode, and cylindrical. Well, I know.
Cylindrical and spherical. And
But they are not standardized. They are reserved only names. Or
they are defined, I think.
okay, the standard is the same. Reserved, cylindrical, and spherical.
Okay, might also be. Okay, yeah.
Is there the intention to add more?
As they are needed. So the question was is if there are intentions to add more geometries, and like I said, we are mostly driven by actual applications using OpenPMD, so we are not saying we add something up front that might find someone using it someday, but if someone wants to use something, then for example, we have a code WarpX developed at LBNL that is now using mesh refinement, which is a standard extension, and the development mode for that one was that the code prototypes it, and as soon as we see that it works, that it's established, that also analysis codes are using it, it's then standardized. Richard?
You defined your grid unit as millimeters. Is there something like set unit dimensions for this grid?
Come again? Is there?
So right now you define your dimensionality, your unit dimensionality for your data, but this could also be possible for your grids. Could you comment on that? I mean, right, it doesn't have to be a length, it could be a momentum, it could be something else.
Yes, this is what I mentioned earlier quickly, that with the current version of the standard, the mesh axes are implicitly assumed to be spatial, and the upcoming standard version, which is currently being implemented, will also support having non-spatial axes.
This is the upcoming 2.0.
Yeah, exactly. All right, so maybe let's try compiling this. CDB. And I did something wrong.
The column between me,
Yeah. Yeah. So this needs to be a comma. There needs to be an additional thing here. Yep. So everything's wrong. Let's hope the rest is correct. No.
Why two round brackets?
Because this is a standard map and this is just one entry.
Okay.
So that comes back to your question. Here for the position, we actually need to specify the type explicitly, because it cannot infer the type, and the same for grid spacing. So let's do that and say we are working with double types. All right. And now inspect the results again. And we see we have the little comment that we put in here. We have the access labels and the other things we defined. We don't have an author yet. We don't have a software name yet. So maybe I will give you a minute or two to try specifying author and software name on your own, and then we'll continue.
Does OpenPMD has a cheat sheet?
It has, kind of, and I've put this already in the Zoom. It's the first read example where you are guided through the most important calls for writing data. I can, yes. All right. So author and software version are defined at another level, not at the level of the mesh, not at the level of the iteration, but instead here at the global level where the series is opened. So let's define that. Let's keep it short. Execute this again. And look at the output see that the data now knows about me. All right, do you still need time or can I continue? Okay.
Why can we see the factor of the